Hi, 8th grade. Welcome to lesson 7-3. Apply the Pythagorean theorem to solve problems. By the end of the lesson, I want you to be able to say, I can use the Pythagorean theorem to solve problems. Let's solve and discuss it. Carlos is giving his friend in another state a new umbrella as a gift. He wants to ship the umbrella in a box he already has. Which box can Carlos use to ship the umbrella? Explain. Well, we got a lot of choices here. So our first choice is we can use this box that's 22 by 22, but it won't fit in any of the boxes like straight laying on the bottom because 37.5 is longer than 22, longer than 27, longer than 27. It also won't fit straight up and down because it's longer than 22, longer than 27, and longer than 14. But maybe it could fit diagonally. Do you see the right triangles? This one maybe I should have drawn it the other way. Okay, so let's use our Pythagorean theorem. Will it fit? Is 22 squared plus 22 squared? It needs to just be longer. It needs to be bigger than 37.5 squared. So we'll do our math. 22 squared is 22 times 22, which is 484. And so 484 plus 484 needs to be bigger than 37.5 times 37.5, which is 1,406.25. 44 plus 44 is 968. 968 is not bigger than 1,406.25. So it's not going to fit that way in the box, which means it's not going to fit on the bottom because that's also 22 by 22. Let's try 27 by 27. 27 squared plus 27 squared has to be greater than 37.5 squared. Well, we already know 37.5 squared is 1,406.25. So what is 27 squared? 729 plus 729. 729 plus 729 equals 1,458. That is greater than 1,406.25. So we should use this box. Should we try 27 and 14? Or are we thinking that's going to be the box? Let's think that's the box so we can save time. If that didn't fit, there's also something I want you guys to see is that there's like this 3D thing going on here. You could have put it also in the box from this corner to this corner, which would use this triangle that's kind of hard to see if you're not picturing it in real life. So I will show you something in real life. Focus on math practices. Tim says that the diagonal of any of these boxes will always be longer than the sides. Is Tim correct? Yes. The diagonal is the hypotenuse. All right, example number 1. Apply the Pythagorean theorem to solve problems. Kiana is using a kit to build the kite shown. The kite includes 3 different lengths of wooden dowels. How can Kiara decide which pieces of wood to use as the diagonal braces for the top or the bottom of the kite? So they tell us that it's 28 by 21. So they redrew a 28 by 21 rectangle at the bottom. And we want to use the kite piece as a diagonal. Well, that's the missing space, and that's across from the right angle, so we know that to be C. We write the formula, plug in the known values, substitute, do the exponents, add, and take the square root. So we must use the 35-inch long one. The length of the diagonal of these rectangles is 35 inches, so Kiana could use the 35-inch dowel as a brace for the top or the bottom of the kite. Let's try it. What is the length of the diagonal of a rectangle with 19 feet width, 19 feet, and width 17 feet? So we use 19 squared plus 17 squared. 19 times 19 is 361. 17 times 17 is 289. So we add those together and get 650. Remember, that's not our answer. We have to square root. So we take the square root. If I can get my calculator open. Take the square root of 650 and we get 25.5 about. If a triangle were a square, would the process of finding the length of the diagonal change? No. The side lengths would just be the same. We'd still use the same process. So the side lengths, or the legs, would be the same. All right, example number 2. Apply the Pythagorean theorem triangles in 3 dimensions. Alex has a column aquarium with a rectangle base that has a height of 66 inches, a length of 10 inches, and a width of 14.5 inches. What is the longest piece of cholla wood that Alex can buy to fit in his tank? So first of all, we have the bottom, and then we have the tallness. The longest piece of wood is going to go from the bottom corner to the top corner. But in order for us to find that, you have to be able to see there's a right triangle here where that is the diagonal for it. But we're missing a side. We only have 66 as the height. We don't have how long this piece is. So in order to find the height, the C, for that we have to do another step and we have to look at this right triangle. So that's what they do first. They use the 10 and the 14.5, plug it into the Pythagorean theorem, and end up getting that D is 17.6. Now we can use 17.6 along with our 66 in order to find this diagonal. Plug in, exponent, add, take the square root. A piece of cholla wood that is about 68.3 inches long is the longest piece of cholla wood Alex can buy. Example 3. Apply the converse of the Pythagorean theorem to solve problems. Sandra brought a triangle shelf to hang in the corner of her room. Will the shelf fit in the 90-degree corner? In order for it to fit in a 90-degree corner, it has to be a right triangle. So we plug in our A, our B, and 30 has to be C because it's longest. We get 900 equals 900. So since the Pythagorean theorem works, it is in a shape of right triangle and it will fit the corner. A company wants to rent a tent that has a height of at least 10 feet for an outdoor show. Should they rent the tent? Goodness. Should they rent the tent shown at the right? So here we've got the height, we don't know that. Then we've got the hypotenuse is 15, and if this whole thing is 24, we're just going to take half of that and know that this is 12. So we got h squared plus 12 squared equals 15 squared. H I don't know. 12 squared is 144. 15 squared is 225. Trying to solve for h, I got to get rid of the squared and got to get rid of the 144. So I'm going to subtract 144 from both sides. It's canceled. We get h squared equals 81. Take the square root. You get 9. Key concept. You can use the Pythagorean theorem and its converse to solve problems involving right triangles. All right, 8th grade, let's say it. I can use the Pythagorean theorem to solve problems. Have a great day.